Today we're going to be going over the Java solution for Leetcode 79.
Word search. Given an m by n grid of characters, board, and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same cell may not be used more than once. So here, this is like our classic example of word search where we can basically have to find the word in a grid of characters. But this time it's a bit different where normally in word search you can only make horizontal, vertical, or diagonal lines. This one, as long as the cells are connected, you can basically consider them valid. So by connected, I mean by up, down, left, or right instead of diagonals. So here we're going to be given a board of characters. So that's by this input right here, and that's what it looks like. And then a word, a target word we have to find. So A, B, C, C, E, D. So we can see that we have A, B, C, C, E, D. We found it, and we can return true. For this one right here, we're asked to find the word C. And so we see that, okay, S, E, E, we found it. And for here, we're asked to find A, B, C, B. And this one returns false since it doesn't appear in this grid. So we can see that if we have A right here, we have A, B, C, and no B's other than this one. And remember, we can't use the same cell again, so we can't use the same B, or else this would have been valid. So that's why A, B, C, and if we look at these two, none of these are B's, so we couldn't find it there. And then another A right here, there's no B's connecting it, and so this one is also not valid. So to code this up, you could imagine we're going to use some sort of search algorithm. You can use depth first search or breadth first search. For this one, I'm going to use depth first search. So before we begin the actual logic of this, we're going to have to go through all the characters in the grid to make sure that we have looked through all the valid cells. So we can make a double for loop. So for int I is less than 0, I is less than board.length. So these are all the rows. And now we're going to go through each of the columns. There we go. So now what is it that we're actually looking for? Well, if we think about this logically, if we were to ask to find this ourselves, we would probably look for the first letter of the word and then try to see if any of the other words connecting it are also part of that word. So for example, we would scan through this whole thing trying to look for any A's. Once we found them, let's say we were looking from the bottom to the top. Once we found an A, we would look to all its directions and see if we can find the next letter, which would be B. In this case, we can't. Then we look through again, and we found this A. Then we look to the side of it. We see that there is a B, and we also find there's a third letter C, and the fourth letter C, and the fifth E, and then the sixth D. And now that we've completed the word, we can say that it does exist in this grid. So what we're looking for is if board of ij is equal to word.char at 0, so the first word or the first letter of the word, then we can execute our search algorithm. So our depth first search method, and what we're going to do is if, and this is actually going to be a boolean, so if this returns true, then we know that we found it. So the method is going to return true or false depending on did we find the whole word or did we not. And if it does return true, then we know that we found it. And if we can go through this whole grid without ever returning true or ever finding it, then we know we haven't found it. So we could return false. So what will this method actually take in? Well, we're going to need the coordinates. So int I, int j. We're also going to need the board. So char board, and we're also gonna need the actual word itself. Now, also, we're gonna need to know which letter we are looking for whenever we execute this message, and this is gonna recursively call on itself. We're gonna need to know which letter we're looking for. So we already found the first letter, and so if we were to call this again, we would presumably look for the next letter. And so letter would be 1 this time, and then we would look for B, which is the second letter of the word. So how would we actually know that this should return true? Well, if letter is equal to word.length. So we've basically went through the entirety of the word and we found all of the letters that are associated with it, and we were able to finish the whole word itself. So we know we found it, and we can return true. So let's just put those stuff in here. So I, J, board, word, letter, and then we can do our boundary checks. So if I is less than 0, or J is less than 0, or I is greater than or equal to board dot length, or J is greater than or equal to board of I dot length, or board of I and J is not equal to char add letter. So this is a case where it's not equal to the letter we are looking for. Then we can return false. Now, once we've done that, all we need to do is that if it doesn't trigger this if statement, then we know we're in a valid cell. So we can recursively call on the other 4 directions with the next letter. So if we call on that, we're going to need an if statement for it, since it's going to return a true or false. So DFS of ij board word and letter plus 1. So this is the next letter. Let's copy this and then do it for the 4 directions. So I plus 1, I minus 1, j plus 1, j minus 1. So all we need is for any of these to return true. Since if any of them do, then that means this was triggered, and we know that the word was found. So if that's the case, we can return true for this method as well. Else, we know we could return false, so we'll just say return false. Now, if we run this, we'll see that there was an error. Oh, okay. Word where was that? Word and letter. I didn't make it. Oh, sorry. I meant to put in 0 since we are looking for the first letter of the word. So we can see here that we pass case 1 and 2, but case 3 we don't. And the reason for that is, like I said, as we were going through the example, we can't use the same cell again. So what this method basically did was that it saw the A, and then it saw the B, then it saw the C, and then the C called the method in all the valid directions, which are up, which were, down, right, and left, and it saw that, wait a minute, there's a B right here. So then it went here, and it realized we finished the word, and it returned true. But we can't use the same letter again, or same cell again. And so we have to basically restrict it from using this. So we can do that by making a separate grid that we can call visited. And basically this is going to tell us if we have visited that cell. If we have, then we don't consider it. It's an invalid cell. If we haven't, then we know that we can consider it, assuming all the other parameters in our boundary checks are valid. So visited is going to equal new boolean board dot length and board 0 dot length. So now, since this is global, this method can access it as well. And we got to add another boundary check, that being that visited of I and J. So if visited is true, then that means we know that we can't consider it a valid cell since we've already visited it. So we can also return false. And then after that, if this if statement isn't triggered, then we know it's a valid cell. We haven't visited it, but that means we have to make it so that we have visited it. So we have to turn that into true. Then this if statement is going to run. It's going to look for all the 4 directions, and if we find the word, then great, it's going to return true. But if we don't, then we got to make sure to turn all of these visiteds back to false. So whenever we go through the next iteration, when we find the first letter of the word again in a separate cell, that we don't confuse it with the previous iteration where we said that, no, we have already visited it, when we in fact just had started it, and we actually haven't visited it. So we can say else visited of I and J is equal to false. So let's run it. This should work. Hopefully no compiling errors. And great. Now let's submit it. Alright, great. So that was Leetcode 79 word search.